Rational zeros and rational roots problems are some of the trickiest problems in Algebra 2. However, we have to understand some basics. So for instance, function of 2 equals 0, it pretty much assumes that 2 minus 0 is a factor. In your textbook, you probably have f of c or f of x equals 0. Well, you wouldn't have f of x, you'd have f of some other number. But in our textbook, we have f of c equals 0, so x minus c equals 0. And then the zeros are just part of the rational roots. The zeros mean that whatever you have should come out to be 0. Like if you're doing a problem with a remainder, it's going to come out to 0. So in respect to P and Q, P is a constant term, doesn't make much sense, and Q is the leading coefficient because you're assuming that P over Q can allow a rational root to be expressed as a fraction. So if you had 2x to the third power plus 3x to the second plus x plus 6, your p is going to go over here. And it's going to be the constant term, but that's assuming we're not going to factor anything out of here. And your q would be these roots here. So those would be 2, 3, and 1. And sometimes when you do them, because you're multiplying, they also become the negatives of those 2, 3, and 1. So you'd have negative 2, 3, 1. Now, if you want to solve for them, the most common method used is through long division or synthetic division. And long division, although it's called long, there is a quick way to do it. So let's look at what we're going to do if we take a look at this equation here, which is 2x to the cubed root plus 8x to the second root plus 2x minus 12. First of all, we're going to factor out the 2 because we're going to make this as less complex as possible. If you don't factor out the 2, then instead of writing your numbers to start doing your long division, you'd write your numbers as 2, 8, 2, and 12. And there's nothing wrong with that, but that complicates things. Because when you get ready to divide this, remember you're doing 1 into this, and then you're going to have, 2 up here. 1 times is going to be 2. You're going to come out with different fractions. And this is going to be 6. You're going to be adding. It's going to come out to 8. And then this is going to be 8, this is going to come out to 4, and you're not going to get your rational 0. So for that reason, it's better off if we just factor things out and try to reduce and keep things as simple as possible. So we're going to go on ahead and factor out the 2. And then the equation becomes 2 times x cubed plus 4x squared plus x, minus 6. So 2 times x to the third plus 4x to the second power plus x minus 6. And then your coefficients are now going to be 1. Ignore him for now. He's factored out. Ignore this 2. It's going to be 1, 4, 1, and negative 6. Don't forget to include that. Okay, so then when we go over and we're doing 1, 4, 1, negative 6, don't worry about this diagram. We're going 1 times 1 is 1. 1 times this one is 1. So 4 plus 1 we are adding is 5. We did not add here. We brought it straight down. 1 times 5 is 5. So when we add here, we get 6. And then this blue line comes back and gets a 6. 1 times 6 is 6. This was a minus 6, so this is 0. This now proves you have a rational root because you ended in 0. This is complicated, and your math teachers are really, really smart people who know how to do this. it gets complicated though, but you just have to settle for this and just say it has to be a rational root equation because I have a 0 as my quotient, meaning I don't have a remainder. So these are real roots. But in order to go back and find out what the real roots are, so you divided them into, you're going to have to do something, and you're going to have to take these numbers, 1, 5, 6, and make it a new equation. And this is how you do that. You factored out a 2, and we left it alone. Put it back, x minus 1, and then this says x to the second root, 5x, and 6. Why do we know the degrees? Because this 6 has to be a constant. You know why it has to be a constant? Because this one can't, 0 can't be a constant. So this is 5, at least not in this equation. So this is 5x, 1 degree, and then this over here is your second degree. So I hope everyone sees that you now can look at it and say, well, that has to be 1x, that has to be 5x, and this has to be my constant c. So you have your original quadratic equation of ax plus by equals your c term. So now you can factor, but again, you are factoring according to the rational roots theorem, which is this here. X minus c. When you factor out this equation, and you have x minus 1, so you don't have to worry about factoring this out. You're going to factor this. If you see this 5, 3 plus 2 equals 5. And 3 times 2 equals 6. So you have x squared plus 2 plus 5. So when you get ready to factor this, you have x plus 3 plus x plus 3 times x plus 2 should add up back to this. And when you do your FOIL method, this is x squared. This is 3x. Plus 2x. And then this is 3 times 2, which is 6. And when you get ready to add these back, you'll see x squared, this 3x and this 2x is 5x plus 6, because you can add these two like terms. So it factored well. And we do have roots of the equation. Let's find out how these numbers here, this x plus 3 and this x plus 2, become a root. Or I should have said become roots. Okay. You have a 3 and a 2 here. So q, because those are your coefficients, 3, 2. 1 is always assumed when you're dealing with rational roots. And your constant here was 6. So this was your constant equation that came down to the p-value. Doing a bad job of drawing here. That's 6 to this p. So you have your roots of 6, you have negative 6, you have 3, you have 2, and you have 1. And why is that? Because 3 times 2 equals 6. And, also the 1 is already assumed. And so those are your roots and your values. That cuts down what your roots really are. So when you get ready to write, your teacher's probably going to have, is it these for P and these for A? And if you kind of can see the numbers and see what's going on, even if you don't do the equation right, if you can get this part, the factoring, after you do this mess over here with the 1s and the 4s, and I call it a mess because this is where most people get confused. And a lot of people sometimes, even including me, I don't like to factor a lot, but if you don't factor, you're not going to get the correct equation. Okay, so that's for that part.